Well, we're gonna start because y'all are here and I get introduced. So thanks everyone for coming to my session about visualizing the health of the internet. I know that's kind of a big question, but something we're all thinking about, given everything that's happening with net neutrality. I hope you're keeping up. As I was introduced, my name is Irene, and I work at Boku, which is a consulting company here in Boston. We're a group of engineers who love to work on open web-related problems. We work with clients on either open source projects or making use of open source in their products. And I specifically work on the data visualization team there, where we do a lot of data science and visualization kind of work. If you're interested at all or need help in any of these domains, definitely drop us a note, hello@boku.com, or come talk to me or my colleagues here. But I want to talk to you guys about Measurement Lab, which is a project that was founded in 2009 and is actually a collection of different organizations that came together to create an open platform for researchers to be able to study the health of the internet. Now, if you think about it, the internet, it's pretty global, it's everywhere. How can you possibly look at it as a single entity, right? So obviously, a pretty big challenge to overcome. And the best part about Measurement Lab is that it is very, very open in a lot of ways. Not in all ways, but in a lot of ways, in that its data is open and available to everyone. So any of you can go and download it, which is a fairly large challenge that I'll get into definitely, which is why this project exists. But this data set has been collecting internet health measurements from 2009. And this data set is huge, and it's all global, it's all around the world. And it can really provide you a pretty good picture about how the internet is doing, and a lot of people are studying it in various ways. So I'll kind of dive in a little bit into the area that we're specifically working in. So the reason MLab was founded, as I mentioned, is really to kind of create this platform that can be worked on in the open by a variety of folks for three main reasons. One, in order for us to really study the internet, we all need one big global data set that we can work from. So if I collect data in Massachusetts and someone collects data in Bangladesh, is our data going to be the same? Ideally, it's all a part of a single data set, the same format, on a single platform that is really using the same measurement protocols. And so we really wanted to create this huge network of servers upon which this platform can be deployed. The second thing is, especially when this was founded in 2009, sharing terabytes of data across the world was kind of a big challenge. It probably still is in a lot of ways, right? So you can imagine that making sure that everyone has access to this large data set all around the world was definitely one of the problems that MLab wanted to solve. And then the last reason, which I think is really important still to this day, even more so, is that legislators, people who sit in government, local and national, have to make decisions about broadband connectivity all of the time, right? Things like mergers come up between service providers, and they really, really don't have data to make decisions on. It's amazing, but they come to Measurement Lab all the time to ask them questions like, oh, this ISP wants to merge with this ISP. Can we look at their behavior in these particular regions, and so on and so forth? Or we have various client complaints around people not getting the performance that they expect. We don't know. So it's pretty important to be able to enable the people who make policy decisions with data, as you can imagine. And so I linked to sort of the founding paper of Measurement Lab if you're interested in learning more about the context of when it was founded. And so the way Measurement Lab is set up is there are sites all around the world, and this number is growing, and a site has one or more servers. And the servers are connected to what we call transit ISPs. So there's two types of service providers. There's your client ISP, which is your Comcast, your Time Warner, your Verizon, whoever you subscribe to, and transit ISPs that provide the rest of the connectivity to the data centers that are out there. So Cogent, Level 3, so on and so forth. You guys generally don't interface with them, but your client ISPs and transit ISPs have business relationships that empower these connections. And there's, as all business relationships go, those can actually impact the level of service that folks get, which is obviously not legal. So anyways, Measurement Lab has in all of these sites different servers that connect to those different transit ISPs that come to a single data center to be able to measure the way that those interactions with those transit ISPs look like. And so the way the data gets gathered, obviously that's important, is that users run speed tests. So Measurement Lab provides an API and a set of libraries and tests, and people have built lots of infrastructure around it. So Measurement Lab has its own website where you can go and run a speed test. It also has a Chrome extension that I love. I run it every day, and I call Comcast once a month and say, hey, why is my bandwidth so terrible? And they say, we don't know. And it's a really frustrating conversation. And we actually also are starting to see cities all around the US starting to really wonder, is the service that their consumers are getting actually what they're promised? Because they're handing out contracts to service providers, right? So if I have a housing development or a library or a school, I'm going to give that contract to some kind of a service provider. And then I, as a city, have no idea whether that school is actually getting the level of service that they're promised, right? Which is a scary thing. You sell, you get a product and you don't know if it's working. So users run tests to kind of get their own speed, and then that data also gets saved on all of these sites around the world. And then there's a crazy, amazing pipeline that their colleagues in Google who work on this project that goes and collects all of this data, and it takes several days for it to percolate because some of this data is actually on servers where the connection is so slow, incredibly slow, half of a megabit per second if we're lucky, and aggregate all this data and augment it and so on and so forth. And so the measurements we care about the most as consumers are your upload speed, how long does it take you to share your photos, your download speed, how long does it take you to download something totally legal but large from the internet, and then your latency. When you're playing your multiplayer real-time game with your friends, is your particular shooting of people is super delayed. Whatever it is kids do on the internet these days. Anyways, or your Netflix streaming, that's a better one. So these are really the measurements that we're thinking about. There's some other ones. We look at latency, we look at retransmission rates. So if your packets get lost and they have to get resent a lot, that's kind of a bummer. But these are really the consumer level things. And as I mentioned, our client ISP connection obviously is important, but really the full route is something that we need to start thinking about, right? Because if we're very lucky, we live in the US. As far as we know, the government is not throttling our internet, but there are definitely parts of the world where that totally happens, maybe before elections or other kind of situations. And so even though your connection to your ISP may be great, maybe the rest of the internet is being throttled at another level. And so I'm sure all of you have run a speed test before. For those of you who don't really quite know what happens when you make a request on the internet, let's say you go to www.cathats.com, which is a website that's hosted, for example, in Turkey, and your request is going to bounce around lots of routers along the way before it gets to the data center where this website is hosted. Somewhere along the way, pretty early on, is going to be your ISP, so your Comcast or whatnot, whomever is kind of connecting you to the rest of the internet. And then somewhere there'll be some ISP in Turkey or some transit ISP that's connecting to that data center. And so what happens when you run, let's say, speedtest.net, I'm sure everyone's gone to speedtest.net, it's only going to measure this first leg to your first ISP, the first ISP router, which on one hand is nice, but on the other hand is really not realistic at all to how you interact with the internet, because you're actually going to get some kind of content, right? That's what you really want. And so what Measurement Lab is doing is trying to replicate your actual interactions on the internet by basically putting content on all these servers that are scattered around data centers where actual content lives, where your YouTube videos or your apps or whatnot lives. And then it just measures the actual performance of your request along this full line. And you can, normally would choose the closest site to you so that, it actually replicates maybe the kind of traffic you might go for. But if you really wanted to see how long it takes you to get data from, China, sure, you can pick a server there and see how that looks like. And so this is, in some ways, ISPs absolutely hate Measurement Lab because the data that we show you generally is going to have your speeds are going to be much slower because at the end of the day, your internet behavior is impacted by everything that lives along this full chain of requests. And so, but that's also the reality that everyone lives with. So our goal was to build a web application that lets us look at the performance of the internet along three main axes at a specific location, which could be anywhere from a city to a region. like Massachusetts, to a country like the United States, or a continent like Antarctica, which you can totally look at the internet quality of, over any time period. So, on a specific day or a month or a year, at those granularities, and then over a specific time period. So I want to look at the year medians for download speeds in Antarctica from 2012 to 2015, for example, right? And then really more specifically to look at actual internet service providers, both client, consumer, and transit ISPs. And then the key was to do this in any combination. And the main reason for that is that we have a pretty diverse audience that we need to cater to. So obviously we have consumers, so folks like me and you who may wonder why the internet in Cambridge is so terrible, and you just want to go and look at, is it terrible for everyone or just for me? It's for everyone. And so you want a place to go do that, but there's other folks. There are researchers all around the world who are looking at anything from internet performance as a whole, the socioeconomic impacts of having good or poor internet connectivity. Folks who are looking at how to actually improve the infrastructure, the actual physical infrastructure of the internet. The internet's pretty old in parts, and so on and so forth. And so they're really thinking about impact. We also have advocates, folks who are trying to fight for net neutrality, for example, and really need the data. People who maybe detect that there's some kind of throttling in their country and they need information to be able to surface this to the rest of the world. And then legislators, folks who need to actually make regulations and decisions, evaluate civil complaints and things of that nature. So obviously it's a very diverse set of consumers, a little bit challenging to try and tailor to all of their demands, right? And so we needed something that was both really simple, but then also really easily catered to everyone. And so I'm actually gonna try and do a demo. As they say, death by demo is a fun thing to do. So you can all check it out if you go to viz.measurementlab.net, although don't do it right now, but you can. And when you get there, you can very clearly do a few really basic things. The most important and common thing that you may want to do is look for a specific city or region. You can also just look at a sample of traffic, some of our tests over the past month or so, and you can sort of see clients show up in this gradient. The slower clients are going to be blue, and they're going to be basically in South America and Africa. And the faster clients will be in like North America and Europe. We know that's true, but also still really sad to see. But most likely you're going to want to go and look at a specific location. So let's say I'll go to Cambridge, Massachusetts, where I live. Sorry, I'm so self-centered. And it will go ahead and pull up information. This is kind of updating real time as it's pulling in the data. It turns out MIT and Harvard are actually ISPs, even though you can't subscribe to them, and their internet is pretty bananas. So thanks for that. So I'm actually going to go ahead and add a few other folks and remove these ISPs. And so I'll add Comcast and Verizon and RCN. And you can sort of see what the data looks like here. So we're getting about, if we're lucky, from Comcast, 25 to 30 megabits per second over the past year. And this will sort of show you the amount of tests we have. And then you can kind of switch around and look at different measurements. So, download and upload speeds. You can also look at different aggregates. And then it kind of gets into more details. One thing that we care a lot about, and this is crazy, is how the internet performs for different hours of the day. So if you try to, let's say, stream a video from 7 to 11 p.m., are you going to have worse performance than you would the rest of the day? That's also pretty key. So we aggregate lots of information around that as well. Yeah, so all these visualizations are done in D3, and actually a bunch of this work, all this work is open source, and I'll point you guys to the repos as I go through it. But all of these graphs that we've made are also available, and we've contributed several different modules around line interpolation and animation to kind of simplify some of these things. And so the next thing that you can do, if you're really one of the folks who need to look at this data at a more granular level, is look at this compare view, which lets you compare across location, ISPs, transit ISPs. So, if I wanted to, let's say, look at the traffic in Boston versus the traffic in New York, I can just pull those up and look at how they compare over a certain time, their download, upload speed. So New York has slightly better internet. I'm not into that. I can also look at just client ISPs. So if I want to look at Comcast, and let's see, do it. There we go, Comcast. So I'm looking at, I don't know if you can tell, but Comcast has 40 million tests for which I'm pulling the data right now. So, pretty fast versus, let's say, Verizon. 11 million tests. And you'll notice there's this really interesting dip here. This is actually something that we just found recently or are investigating because we still have lots of tests in this time frame, but the dip is real. So there's kind of an ongoing investigation of what's happening with these ISPs. And so on and so forth. And I think one of the best parts about this is that we've tried to make the data really available. It took us a lot of effort to get to a point where the data is so aggregated that we can make custom time queries for custom locations and get it real time. And so we built a REST API and also a static data download. So people like to generate reports that are like, internet speed in India in 2016, and they just want one number. So you can go and get that. But you can also get, nope, this is all free. This is all free. Y'all can use this right now. You can destroy my API. That's totally fine. This is our REST API, and it's all documented. So for example, if you wanted to get all the data for a specific location, let's say North America, US, and New York, and it's going to have some defaults for the dates. This will be the result that you get. So you can just try it out. You don't have to deal with all of our data. But having said that, dealing with all our data is really fun. So I'm going to go back to our actual presentation, and I'll skip all this because I showed a few for real. And we've already, even though we launched this really only about a month ago, we've seen already some really successful stories of people having access to this data. So there was an ISP in Zimbabwe that ran a promotion in December of last year, during which they actually raised the bandwidth limits to get more subscribers. And then once they did, they just dropped them right back down. And so folks who obviously were pretty unhappy about that were just able to pull our data and show it in this one really quick graph. And then we were also, there are folks who are fighting for, as a result of some regulation changes in Brazil that you can just see this really steep drop because some regulation changed. And it's funny because if you look at internet reports in Brazil that are trying to bring in business and things of that nature, they all conveniently stop in July of 2016. So if you look up, I think Speedtest has one of those as well. So. I am not really sure the reasons, but certainly one of the concerns that folks have obviously is the way that the internet traffic is routed. So one part of the data that we're not working with is every single one of the tests that we have data for, we also have the full trace route. So every single router that it stops in, how long it waits there, and the router it goes to next. And so we're looking for funding to build out that because you can totally look at the entire network of the internet. So hopefully that will happen. But as I mentioned, everything is open source, and they're all located under GitHub m-lab organization. And I'll kind of go over these three repos. We have basically three separate projects. There's the REST API, the actual ETL pipeline that takes and deals with all this data, and then the client application, so what I was basically demoing to you guys. So I'll talk a little bit about the data pipeline first. It's a little bit my baby. And the data that we're working with comes from a test called NDT, Network Diagnostic Test, which both reports these metrics of upload and download data, but also tries to determine what kind of problems exist, if there are any. So it'll detect congestion. It might give you some possible explanations for it. And really, the base of the test looks like this. It's this text file, and it's got really the source and the origin and the destination information, just as IP addresses. And then all the measurements are just a list of numbers that you can parse, that you can just parse. We don't work directly with this data. This data already gets converted and put into BigQuery. So we work in the Google Cloud because our partners at Google have given us unlimited resources, which is amazing. So there are two ways that you can work with this data. One is you can actually just download the raw data. There are tens of thousands of files. Good luck, have fun. I did not do this. I downloaded a few of them and then thought, nah, this is too painful. But they are all available, and there are many researchers who work with them in this capacity. And it is free to download. There's no data caps. It's just really your patience. But then, realistically, a lot of the data is stored in BigQuery. That's how we interface with it. It's one giant table. And this is, as of I think last Tuesday, how much data we had. We had 820 million tests, which translates to about 243 terabytes on disk, of which we only think about 100 terabytes is the data. But, and this is from friends who have root access to the machines where the data is stored, but there's so many machines that we kind of just agreed that data so large we're not sure how much we have is probably the appropriate way to describe it. I'll go through the pipeline, yeah. And so our BigQuery schema kind of takes that NDT test result and converts it into a more SQL-like structure that should be familiar to you. And really what we care a lot about is the download and upload flags. So we have a separate test for download and upload, even though every person runs a test that results in basically 2 entries. And then the IPs for the client and the server, and then the actual measurements themselves. And I'm both linking here to the schema that has all of the different properties. There's over 100 of them. To look at all kinds of measurements that we're not even using. And then there's actually a really convenient little generator that one of our teammates at Google wrote that will make sure to get valid tests, which is really important. Some tests don't complete, they don't transmit enough data, and we get interrupted, maybe the user stops, and so on and so forth. So we really want to make sure to filter those out first. And so this is just an example of one of a piece of our query, which is pretty big. We care a lot about the location. So by the time we get the data, that's already been resolved. We know that it's Cambridge, Massachusetts, US, North America. We have latitude and longitude of those regions, not of the actual people sending the test. So it's fairly anonymized. And then we have to compute all throughput and round trip times and things of that nature. That's everything on the other side in small letters. And I will put these slides up online, but you can also look at our actual repo to see some of these. So we do a lot of these aggregations in BigQuery if we can, because it is relatively fast. And you can actually very conveniently just do some of these requests just in the client. Now, there's a limit to how much data you can get through the web client, obviously, but you can definitely test out your queries there. And MLab has a really great quick start guide that I linked to in the bottom. And that's just the test that I was showing you with the 800 million results. And so the best way to get a lot of data is actually when Google decides to integrate your tests into their one-box integration. So now if anybody in the US searches for internet speed test, they will see this beautiful box that the Google search team decided to integrate. They'll just say run the speed test, and you'll run it, and you'll get this really beautiful display that will tell you your internet is really sad, thanks Comcast. And that's my internet speed. I pay for a lot more. It's great. And it's been piping so much data at us. It's been like delightfully overwhelming. And so we're trying to investigate whether that's a part of the reason that we're seeing this bump. You can see the test numbers spiking over there. That's still in the million. Like the lowest notch on that tiny graph is 2 million tests. So it's not like we didn't have tests before, but this is approximately when we saw the launch. And so either the data is normalizing or something weird is going on over there that we're trying to do. But then we still have a more complex data pipeline for things that we can't just do super easily in BigQuery. And really there's 3 main things that we have to do. The first thing is we have a client location and we have a time, but the time is a UTC time. So we have to convert it to your local time because 10 a.m. Is going to be different, and we actually want to know what the internet was like at 10 a.m. Wherever it is you are. The second thing is we do want to create all these aggregates. So we look a lot at medians, obviously by hour, by day, by year, by month, in various combinations, because when we actually do the range query, we're not going to be computing that from millions of tests. We're just going to get the pre-aggregated information for a specific time range at the granularity you asked for and give that back to you. And then the last thing is we have to try and reverse engineer from your IP what is the provider that you're subscribing to. So are you on Comcast? Are you on Time Warner? Which is a really intricate thing that I could talk like an entire talk about, because ISPs own IP blocks, and those IP blocks get traded around all the time. And so your IP might change because now it's owned by a different provider, and then providers merge. So that's a whole thing. Anyways, there's a kind of an open source-ish data set that tracks a little bit of this that we've been using. But there are lots of folks who have this data for real behind closed doors, and it would be really great to get it out. But we do our best. And so what we use is called Dataflow. It's a Google product. This is just one of the pipelines, and this is kind of the graph that gets generated by Dataflow to kind of show you a little bit of what we're doing. It's a little bit hard to tell, but Up in the top, we're just reading our data out of BigQuery, and it goes through lots of these different steps that conveniently gets auto-parallelized where it's possible, not everywhere, obviously, to do things like resolve the IPs, add the local time, and then all the way in the end, write the data back out in this exploded form with all the information we need to a new BigQuery table. And then there's a second step that I'll get to. I wanted to talk a little bit about data flow. It's a really pretty great project because it provides a programming model that lets you do both batch and streaming parallel data processing. And it's based on Apache Beam SDK, so the code for data flow is open. We run it on the Google Cloud platform on Dataflow, but it can also run on open source runtimes like Spark or Flink. And so I highly recommend checking it out. And the way that it's really set up is you're going to have a pipeline, and your data gets read into what's called a P collection. And that can come from anywhere. We read it from BigQuery, so you can read it from file, you can read it from other sources. And then that data gets transformed through what's called a P transform, and it just gets put into a new P collection of some kind. And so we sort of have these streams that go through our pipeline. If it's OK, I can go back afterwards. Yeah, I just want to make sure I have enough time to cover everything. So there are 3 kinds of P transforms that you can really do to your data. You can modify or augment individual rows, individual elements in your data. So in our case, we add the local time, for example. You can also do composition, which lets you group elements together. So for example, we have to group time zones because there's daylight savings time and non-daylight savings time data per time zone. And in order for you to get the local time, you have to reverse engineer whether a certain date happened during daylight savings time or not. And actually, every year, that can change in certain locations. So another thing, another little curveball. And then obviously aggregation, which is things like getting medians for different measurements and so on. And I linked to a really great talk that I think introduces this model really well. And so this is just a small example of one of our simplest pipelines. This is really adding our time zone data. And so here in this first phase, we're just reading it from BigQuery. And then we're building a lookup map. So we extract the time zone name, and then we build this group, a group map of that. Because as I mentioned, for every time zone, there's actually different times, depending on daylight savings times and years when those changed. And then we basically resolve that by piping our data through. And so this is a really small transformation, but our pipeline's sort of built up of many of these. And then at the end of the day, we just have this series of pipelines that build into a pipeline. I don't know, it's probably a different word we should have picked. It also made me think of this game I used to play as a kid where you're just trying to get your pipeline sorted. But you can basically see us reading our data in the beginning, and then we add the ISPs, we add the MLIDE set information, we add local time, we add location, and then we just write it all out to this new big table, this new BigQuery table. And so the nice thing is that we can make a new BigQuery table, but it's still really slow. So if I wanted to still do a lookup, I still have maybe millions of tests for a specific date at a specific location, right? So that's not going to work. And so what we do is we then use Bigtable, which is just the key value store, lots of those around, that we pre-build for all possible permutations. So we'll do 2017 for Cambridge, Massachusetts, for the US, all the measurements, 2016, but then we'll also do it by month, then we'll also do it by day, then we'll also do it by hour. So that really, when you request some kind of a range, all we're doing is we're building the set of keys that you asked for, and then we go and we fetch it from Bigtable. And Bigtable is super fast, and so it's really easy for us to do because we basically do no computation as a result of your query. Key value stores, they are the answer. And so but the thing is, as you can imagine, there's a lot of tables that we're having to generate because of all these different permutations of time and location. And so what we actually do is we sort of automate that by having lots of these JSON files that specify the unique key, which is usually just a combination of fields. In this case, it's a location and a date. And then all the columns that we want, and we auto-generate those, so we have a few hundreds of those. And then we have a pipeline that runs this in parallel, and this is just a GIF meant to make you feel a little seasick. It's pretty long, goes on for a while, generating all of those big table queries, again, through Dataflow. And so it does result in slightly less data, All of our big tables take up about 3.6 terabytes on disk. Still think that's pretty good, and it's stored over about 30 nodes, which is thankfully an auto-scaling function. We don't really have to think about how we sharded, but that's one of the advantages of using the Google Cloud. And our pipeline takes about a day to run. And so because all of the data gets aggregated from the MLab sites only once a week, or at least it takes them so long that it's effectively once a week, once their pipeline completes, our pipeline runs. And so the data is about a week old on the site. And then every so often their pipeline will break and nothing will run from us. So that's also a reality that occurs. And so a little bit about the data API, the actual REST API that we had built for it. As I mentioned, you can do the raw data download. And this is the same thing that powers our client application. So this is the nice thing is we built the REST API for everyone, but that's also how our web application is powered. And you can try it out as we have. So this was an example using North America. And then just a little bit about the front end itself, obviously. We use React and Redux for managing the actual web application and the store, the data store that does all of the state sharing between components. And we use D3.js for a lot of the components. They are all written by hand. I'm sure many of you have seen things like high charts and other things of that nature. We generally build our own to kind of really be able to hone in on the performance and the functionality we look for. And then we use Webpack to actually do our production builds. If everyone has to always do the very standard, I got to minify, I got to compose all my different JavaScript files, and especially as applications get so much bigger, hundreds and hundreds of files. Webpack is a really great new player in this space. If you're using, Makefiles or Grunt or Gulp or whatnot, if you ever need help with Webpack, definitely come talk to us. We have a lot of folks who contribute to that project. And then Karma for our testing. There's lots of automated testing around some of the transformations we do, some of the pipeline pieces, and so on. And so the way that we built the front end, obviously we had to design it, and we have all these different users. And our process is a little bit different in that we are both user and data-centered design process. So we kind of do both of these things in parallel. We both we have our stakeholders and we do user interviews and other kinds of activities to try and get to a set of requirements for what we're trying to build and what kind of functionality that they need, while simultaneously doing some exploratory data analysis and getting various data findings that can then inform our wireframing and prototyping, and we revise and get lots of feedback on those, and then we go forward to building and deploying pretty continuously, which is really helpful. By the time that we're building something, we're already pretty sure what it's going to be, which is really helpful. We try to spend, get as much information as we can kind of really early on. The reason we do the exploratory data analysis, really in Python notebooks, we have dozens of Python notebooks for this project, was really to make sure we're on the right track, verify data structure, confirm expected results. We do some prototyping of whatever algorithms we need to implement. This was really a great example of some of our original initial data analysis looking at the first data set revealed that there was this really weird drop in 2016 that no one knew what it was about. And turned out there was a box somewhere, this is data for New York, that started basically running tests like every hour and getting really terrible results. And because we're getting the medians, it was really skewing the data set on the lower end. And so we kind of realized that we had to first normalize by IP address before we get the medians and so on and so forth. So this was a really quick way for us, in a day or two, go through the data, make sure that things are looking right. Even when you're working with a sample, that's often enough to be able to find things like this. And then we do a lot of different sketching at different fidelity levels. So anything from these like this chicken scratch in the top right, all the way to like much more finalized mock-ups that we do in Sketch. We like to make up logos for our projects. This one's pipes because of the pipes. But it's really helpful for us to get feedback really early from people. And it's really quick to adjust things like priority for different components or the kind of navigation patterns we're anticipating. So you can see things got rearranged a little bit, but that's because it was really quick for us to say, no, actually, I really want this at the top or this in the top. And even though these things are fast to do in code when everything's really modular, it's still so much easier to get through when you're just doing things in paper. And so as I mentioned, reusable components make it really easy for us to be able to extend the UI. I didn't go through the full site, but we're using the same graphs in lots and lots and lots of different places. We care a lot about modularization, so all of these components are very independent. Their parameters are clearly defined. They really do not rely on each other except through composition. So we do have sort of classes that contain other classes and so on and so forth. And they don't talk to each other in any way. Everything uses the shared Redux store. They update when data updates in the store and so on and so forth, but really not through each other. And so that's really great. We were able to, a lot of these components are available. You can just take them and use them, honestly, in your projects if you needed to. Although they're pretty tailored to the specific data set, obviously. And so I do want to talk about some challenges that we ran into that I think are really important. Probably a lot of projects working with large data would run into, or big data, I should say big data. Long-running pipelines make for slow debugging. Once you get past the hurdle of this code is broken, you can run into issues that are just challenging to debug. What happens if your pipeline breaks 5 hours into its run? What happened? Did you get a test that you didn't anticipate? Did the format change somewhere in 2013 and you didn't know about it? Things of that nature. So it still makes for challenging debugging. You're running on the cloud, so best case you're getting some kind of notifications. You're looking at logs. You're building another system to monitor the logs to make sure that your pipeline's running. It's kind of this catch-22. We got really lucky that we got access to this infrastructure, racking in these thousands of dollars of bills a month, but that's not realistic for a lot of people, and we're very, very aware of that, which is partly why we built the REST API. It's not cheap to be running this infrastructure, especially for an open data set. We want to encourage people to access data. We want this to be truly open source, but what does it mean to be open source when you're working in large data? Sure, maybe you can get and install Spark on your cluster, but you got to have a cluster, right? So I think it's a really interesting ethical question for our community. Obviously, data coverage is just a lot better where connectivity is better. So you're going to get lots of tests from New York and Boston. You're not going to get that many from other parts of the world where the internet is not so good. And we really want data for that part of the world. And also, realistically, certain parts really rely on the mobile infrastructure as the primary connectivity source. And our data really does not cover that. It's hard to compare data from mobile devices. It's just a completely different network, right? And then it does still require human intervention. Someone has to go and decide to look at a particular region, to look at how the traffic is looking, to see if there's any particular issues. And without that, no one will know. If a tree falls in the forest and no one's there to see it, did it really fall? I mean, it did. But nonetheless, in this scenario, we just won't know unless someone looks. And even if they do look, we're not always going to know why something's happening, right? I showed you that bump that we're looking into. We really don't know what happened to these two ISPs nationwide, why we saw this huge bump for 2 months. Great question. And we also, at the moment, don't yet have the ability to add any kind of context or annotation. So if things get shared outside of the site, they get emailed around, screenshots are sent, all that kind of thing. But it's really important for us to figure out how to add that conversation back, because without context, we're leaving it really up to interpretation. And as much as I love the idea of machines making decisions for humans, I actually do think humans are pretty good deciders about things that they know a lot about. So ideally, we merge those two in our systems. And so, as I mentioned, we've written a bunch about it. There are some open source modules that our teammate Peter contributed specifically around some of those line visualizations. So D3 is notoriously not great at interpreting lines, as lines have to animate between different states, have different number of points, or when you want to have different shading for the lines to indicate things like missing data. That's what we end up using it for. He also contributed to the React framework, this React URL query library that lets you handle URL parameters as a part of your state, which normally you have to sort of work around, but this kind of merges it with the rest of the workflow that React has in place. So definitely check those out if those are of interest to you guys. And that's my talk. I have office hours today at 3, although I'm happy to hang out and talk to anyone if you have questions, and happy to chat with you more if you want to email me. So thanks. Are there any questions? Yeah.
How do you recruit your test takers?
Actually, the nice thing is that we just provide people the information about how well their internet is doing. So a lot of people will just run it by choice because they feel like their internet is not doing as well. We also have a lot of institutions will just install the Chrome extensions. So those just run tests on a daily basis, for example. So that really helps. And then we're actually looking at creating a box that you can just deploy into your network that's going to pipe this data and give you a picture of how your network is doing while also contributing data to us.
I guess what I'm asking is, are you worried that you're somehow missing internet test takers
Yeah, we definitely worry about that. And we've had in certain, I think it was in Myanmar, there was an organization that actually went out and did testing all around for several weeks. They would just go several times a day and run tests in different locations because data was lacking for that. So we do partner with a lot of organizations on the advocacy side to try and get more of that data through. Yeah. You know, we've heard rumors. I can't confirm for sure. We know that they don't like us very much because they partner a lot with speedtest.net that shows you just those first hops. Their results are always going to be a lot faster. And so there's definitely, I think, some tension there. But, you know, they can't really argue with a large open data set of millions of tests. And so we're going to keep running it. Yeah. A graph tool API. I think it's, you know, the code is definitely there and the big table data is there and you could use the REST API to build the graph. I sort of see no reason not to if you're interested in it. We haven't had a use case for it specifically, but, you know, we're always looking for ideas, so yeah. Yeah, we don't currently, which is definitely a part of the problem. What we'll know is that we may, we're trying to figure out what kind of flags to add into the system so that maybe it'll tell. But part of what happens, there's so many clients that have hooked into the NDT system and just implemented it in their own way. So for example, Seattle is actually asking their users for lots more metadata that gets recorded in their server separately. And it may have to be a similar system where we'll build a specific app that's mobile-based. There's a project called UNI, OONI, that also looks at censorship and other kinds of data, and it's primarily mobile. And so they collect some of that data. So basically, we get all of the tests, and a lot of the times, the clients that will build those testing platforms will route the results also to them and collect some additional information, like a flag that says, oh, I'm a mobile test. But we don't end up having that, although we do have the space to be able to store additional data around tests, so that's a possibility. Yeah, in the back there? We don't. So it's a little bit of a privacy concern. We could, because if you run the test, for example, from a browser that actually can do geolocation referencing, it can give us a pretty accurate IP address. But part of the pipeline before it even gets to us is that data gets a little bit anonymized, and we convert more to a regional kind of information. We would really like to, and that's actually the request that we're seeing the most. So Seattle is one of the cities that did this first, but we're getting lots of requests from other cities in the US because they want to be much more granular, especially around public services. And so we're hoping to be able to build a platform that's more reusable and lets you capture that data in that way. And some of the work for Seattle is open source. It's called Piecewise, and that can be deployed piecewise. Yep, it can be deployed in collecting that data more locally. Yeah. We really don't have the data. I mean, we can definitely determine how many people ran the tests on a specific provider, but we don't have overall subscriber data. It's, because it's opt-in, we only kind of have what we have. And so that's partly why we don't really show a comparison based on that, because we just don't know. Are people on Comcast just more angry at Comcast and thus are running more tests because the internet is terrible? We definitely have less tests, for example, for Verizon. They're still deploying Fios in places, so is it a matter of time, or it's kind of hard to tell, so we can't quite do a comparison on that front. Anyone else? Oh.
So, what the ISP, there's the privacy review to the ISP.
Mm-hmm.
But then there's all these other links and routers to get your so responsible for that.
Yeah, sure. So one of the things that the tool is used for is really to investigate those business relationships between different providers. And actually, a few years ago, MLab released this report that showed that basically in New York, Time Warner was providing a much worse performance to subscribers than other ISPs because of a business relationship that they had with the transit ISP. And so one thing that you can do in the system is basically say, okay, I want to see how all the ISPs work with, let's say, Cogent in New York. And if you see that all of them have about the same performance except for one, then there's probably something going on there. If otherwise, those other relationships seem the same. So this tool is definitely being used for investigating whether those kinds of relationships have some kind of a strange situation, because that is illegal. It's unfair to disadvantage your consumers because of a business relationship between a client and a transit ISP. So that's one of the sources of data that we're trying to provide for folks to investigate that with. Cool. How am I in time? I'm good. All right, thank you so much. Thanks.